Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I have a very interesting special guest to come on the show. We have Josh Aas. I'm sure I said that wrong. Maybe Josh, you can help me by correcting your name. I apologize. One more thing too. He's also the executive director at ISRG, which is maybe a little bit of a mouthful, and you may not know who they are, but obviously you're going to find out that today. Sorry, Josh, go ahead.
No worries. My last name is pronounced Oas. It's a tough one, not very guessable.
The ISRG, right? Maybe you can help to explain what that is, because I think people may not know what it is, unless, of course, they're really into the kind of the topics that we're going to be talking about today, but they're quite important.
Sure. So ISRG stands for Internet Security Research Group. We incorporated that back in 2013, and the original purpose for this was to run a certificate authority called Let's Encrypt. So ISRG is the nonprofit that runs Let's Encrypt, but there are two other projects under the ISRG umbrella as well. There is a privacy respecting metrics service called Divvi Up, and there's the project that we're going to talk about today called Prossimo, where we are working to make critical software infrastructure memory safe. So there's these three projects under the ISRG umbrella. I think all of them are quite important. Let's Encrypt is probably the most well-known, but all three are doing great work.
I think Let's Encrypt was actually started by, who was it started by? Somebody else, right? Or am I remembering wrong?
It was me, Peter Eckersley, Eric Rascorla, and Alex Halderman. So the four of us came from different organizations and, University of Michigan, Electronic Frontier Foundation, Mozilla, and we created Let's Encrypt together.
And was that also your first project underneath the ISRG umbrella to be worked on?
Yeah, so ISRG was created in order to be the hosting nonprofit for Let's Encrypt. It went really well. We're serving, I think, around 350 million websites today. Back when we started, the internet did not have a very high percentage of encryption being used, and today that percentage is quite high. I think in the United States, it's around 92%. Globally, I think it's around 82%, if I remember correctly. But back when we started out, it was a lot lower, under 40%. So a lot of progress has been made. I think Let's Encrypt played a huge role in that, letting people get certificates for free and in a really easy to use way. There are also a lot of other people who helped. The browsers did a great job helping to move things forward. Yeah, we didn't do it alone, but I think Let's Encrypt played a really important role in that and continues to play a really important role in encrypting the internet today.
Yeah, if you don't mind, I just want to talk just a little bit more about it, because to me it's huge. Because I just remember the last things I would do whenever I created a website was for commercial reasons, and I had to go out and buy that certificate. It was quite expensive, and you didn't know which one to buy from, and lots of resellers and all this other kind of stuff. And Let's Encrypt helped, like you said, anybody to basically get a certificate to a certain extent. Of course, as long as you own the domain, etc. But that really changed the game. Like, I don't know if anybody really ever buys certificates except for certain entities for certain reasons, but the process of getting the whole entire thing set up is such a hassle, right? Because I think Let's Encrypt had to first piggyback on somebody else's root certificate, and then finally you got your own. And then in order to actually do that, I think you have to stop accepting traffic from older Android phones. I mean, the whole thing is quite a journey,
Yeah, getting trusted by the vast majority of the internet is not easy. So when we started, we were trusted by, brand new browsers and devices, but that takes between probably 5 and 10 years to get to the point where the internet on the whole trusts you. So for the first number of years, we needed to be cross-signed by another CA. And we have a great partnership with an organization called IdenTrust that cross-signed us for a long time. They still sort of cross-sign us today. It's a bit complicated, but within the next year or so, we'll be completely independent of the cross-sign. And like you mentioned, one of the biggest challenges is older Android devices out there. So that's what, they don't get updates. That's where the trust propagation really hits the long pole, I would say. We're quite widely trusted on our own. There is still a cross-sign, mostly for older Android devices. But we're doing well, and it is a big journey. You mentioned the price of things. One thing that I always like to point out is that certificates being free has almost less to do with the actual amount of money. You know, if we charged even 1 cent, it would make a huge difference in terms of our accessibility because we would have a lot of issues with where we operate in the world because now there's a financial transaction. So there would be a lot more limits on who we can serve. I think even if you can afford a certificate, it puts a lot of friction into the process if you have to get authorized for payment or find a credit card. And then what happens when your credit card expires and you haven't paid again? Do we not renew it and take your website down? I think it's important to point out that making certificates free is a lot more than just about the money. It really reduces a ton of friction in the pipeline of getting a certificate so that computers can just do what they do best, which is automate the work away. Payments introduce a lot of friction that go beyond just the money.
That's a good point that you made. Let's Encrypt. I believe they have the whole entire like suite of tools that automatically renew your certificate or something like that. Or there's definitely ways that you can automate out this process, which is super nice if I remember correctly.
Yeah, we're really focused on automation. We really want to get to a place where people are not manually renewing certificates because that just leads to mistakes, it leads to downtime. So in an ideal world, cert acquisition and management would just be completely automated. So we actually don't ourselves produce any of the tools that people use. We have a great community that produces hundreds of different certificate clients for different contexts, deployment environments. There's no way that we could afford and do a good job of building all the clients that people want out there. But the community's done a great job. We really just focus on making the system and the API as easy to use as possible so that building the tools that the community needs is as easy as possible for them.
After Let's Encrypt, where was the next area to focus on?
The next area we focused on after Let's Encrypt is privacy preserving metrics. So we have a service called Divvi Up that helps organizations collect metrics about their software and their users and things like that, but in a way that protects the privacy of people. So the normal way that you do this is you collect some metrics from a user or a piece of software, and then that gets returned, and then you have a privacy policy, and everybody just trusts that you're going to follow your privacy policy and not do bad things with that data or not track users or something like that. So we want to come up with a metric system where organizations can get the data about their software and users that they need without needing to be trusted to not violate people's privacy. So in Divvy Up, essentially, let's use an application on your phone, for example, but it could be a website or a piece of server software or anything like that. If the question is like, how many times did you press a button? You collect a metric about how many times a certain button got pressed. But then before that even leaves your phone, there's some local privacy preserving stuff applied. And then the number gets split into two pieces essentially and encrypted with different keys for different organizations and then sent off your phone to those two different organizations. So those two organizations do a bunch of batch processing on the inputs from a bunch of different users. And then they combine the results at the end. So when the data leaves your phone, it doesn't identify you. Nobody gets a correct picture of your data when it leaves your phone. The two processors only see partial sums. Then it gets recombined into the aggregate sums for the whole group of users. So in the end, organizations can answer questions like, on average, how many times does this button get pressed? Without ever having data at any point in the pipeline about how many times any individual in the population pressed the button. Does that make sense?
Yeah.
It's a tough thing to explain without diagrams, but metrics are really important how the internet works. If you could see how many times an app on your computer or your phone sends metrics home, it would probably be astounding to you. They're not going anywhere. It is really important for application developers, whether they're on the web or on mobile, that they get information about how to make their products better. So I just don't see that going away. And the answer here is how can we give them the data they need while also preserving people's privacy? So our second project is called Divvi Up. And the goal here is to solve that problem.
It's a very interesting problem because it's really hard to find a decent metric system unless it's Google Analytics, which a lot of people are obviously against for different reasons. And then some of the other ones that kind of compete with it, I think, are nowhere near the what people really want or need, or they have some things that don't really work out so well. Now, after Divvy Up, I mean, is Prossimo the next one after that?
Yeah, Prossimo is the third one, the next one after that. And the goal for Prossimo is to take a bunch of the internet's most critical software infrastructure and make it safer. And specifically, we're focused on memory safety here. So for a long time, we didn't have a better option than C to write a bunch of this foundational infrastructure that we use. I'll throw C++ into that bucket too. So if you're looking at, from the bottom up in an operating system, you've got the kernel, you've got libc, you've got all these other sort of foundational utilities, then you've got various servers and networking stacks and things like that. They've been written in C and C++ for a long time, and those languages are just not safe. And there isn't really a good way to write safe code in those languages. Sometimes people say, well, my C code is safe or my C++ code is safe because I do it in a certain way. Well, history shows, it's safe until it isn't. It's really hard to write safe C and C++ code. I'd say in a significantly complex project like scale, it's effectively impossible. So memory safety is an interesting problem to me because we have so many problems on the internet that we need to solve. But for most of those problems on the internet, we don't really know what the answer is, right? We're still searching for the best way to solve it, whether it's moderation or various forms of phishing and other kinds of attacks. But for memory safety, this problem is interesting because we do actually have the answer. Not even a partial answer, right? The answer is you write this code in a memory safe language and then you don't have this class of problems anymore. So it's interesting because it is so solvable. And what we need to do in order to solve it is not to do a whole bunch more research and figure out what to do here. We just need to do the work, right? We just have a bunch of work in front of us, and it's a lot of work. Rewriting even parts of the Linux kernel, rewriting a bunch of our web servers and networking stacks and things like that in a safe language. That's a lot of work, but we can do it. We have an industry that is very well resourced. There are lots of people out there who are capable of doing this work. There's quite a bit of money in our industry, if you haven't noticed. We certainly have the resources, and the internet is not going anywhere. So if we make big investments in moving to safer software at the heart of the internet today, there's a long time for those big investments to pay off. And the benefits are huge. Memory safety is a straight up consumer safety issue. People have their identity stolen, funds stolen, hospitals get shut down, journalists are compromised and killed. Memory safety is a big deal that has very significant real world consequences, and it's solvable. We can just make this stuff go away, but we have to put in the work. So we are trying to tackle some of the most important pieces of software out there. We're not here to rewrite the whole world in a memory safe language, whether that be Rust or something else. We're focused on, what are the 10 to 20 most important things that we need to move. And we prioritize that by first looking at risk. So what is very widely used, what's on a boundary, whether that's a network or a permissions boundary, what's performing a critical function, and what's not written in a memory safe language. So we look at what is the risk profile of different pieces of software out there. And then we sort of cross that list with the opportunity profile. So is this a library, a component that we can reuse in many different projects? Are funders willing to fund the work? Are maintainers on board and cooperative? So we look at risk and we look at opportunity. We decide what are the most important things we can do. So today we're investing in, one of our biggest investments by far is TLS. It may not surprise you coming from the people who started Let's Encrypt, but we're very interested in making TLS memory safe. So we've invested heavily in a project called Rust TLS. That's going really well. The main person working on bringing Rust into the Linux kernel, Miguel Ojeda, is working under a contract with ISRG. He is doing incredible work. I cannot say enough good things about Miguel. We're investing heavily in video and compression codecs, with our first one being AV1. So we have a Rust port of the David decoder, which we call Ravid. That is going really well. Sudo and SU, we have rewritten Sudo and SU in Rust. We'll be making some more investments and some features there, but that stuff is ready to go today. That team, check out the repo, look at the work they've done. Amazing stuff. They developed such a good test framework that they found bugs in the original Sudo when they were building the new Sudo. We also finished an investment in NTP, where NTP is a time synchronization service that sits right on a network boundary, does a bunch of network traffic. almost all servers run it. So there's now a really high quality Rust implementation of NTP called NTPD-RS. We're going to start in January a big investment in DNS. There's a project that just got renamed to Hickory DNS. Our contractors are going to start work in January. The maintainer of that project has been phenomenally cooperative and helpful. And we've mostly finished an investment in curl, the command line utility that people use to make network transfers. So you can go out today and you can build curl with a Rust library for HTTP called Hyper and a Rust TLS stack, Russells. So you can sort of change most of the networking guts of curl with some build time options and have a much more memory safe curl implementation to use. So that was kind of a long overview of what we're up to with Prossimo, and I'm happy to dig into more details if you'd like.
Oh, I just want to say it's kind of funny that I feel like it's almost like a round circle, right? Because the very first interview episode I did on here was actually with Daniel Stenberg because of the use of Rust recently in curl. So it's kind of funny that, now I get to meet who was involved with that process because I did ask him questions about, who did it, who was paying for this, etc. And just want to kind of mention that as an interesting tidbit.
Yeah, curl was one of the first things we did because we wanted to sort of prove out some of our theories about how we might get this work done. So we found an open source maintainer who Daniel didn't have, and I think still doesn't have much experience with Rust. But if you're going to move stuff like curl over to Rust, you can't always depend on the maintainers and things learning Rust, right? That is a big ask. So we were interested in, can we move these really important guts of curl over to something memory safe when the maintainer doesn't know Rust? And the answer is you can do it. So we built C APIs around the Hyper and Russell's libraries. We built C APIs around them. And then we had Daniel use the C APIs to integrate into curl. So Daniel was able to integrate Rust libraries into curl without ever using Rust. And like I said, that's going to have to happen in a lot of places on the internet in order for us to move to a memory safer world.
He definitely gave some interesting perspective about when you're integrating with our Rust library. There's some things you're not going to be expecting, and but yeah, I think you said for the most part it was pretty much seamless, which is good to hear, right? Because that's kind of what we want. You want, like you said, people to use the safe stuff in places that's very critical without having to sacrifice or do anything different than what they would normally would, right?
Yeah, we're going to take this to another level with Russells. We want Russells to be the most popular TLS stack on the internet. We're going to get there. It's going to take some time. But a really important part of that strategy is our investment in the C APIs around the Rust library, because the reality is that most of the market share is going to come from C programs, not from Rust programs. So when we look forward to how we're going to get the adoption that we'd like, we have essentially, we're going to have three APIs in the Russell's TLS library. There's the native Rust API. Then there is a C API for the native Rust API, which is essentially just the C version of the native API. And then in Q1 of 2024, most of the work that we're doing will be on a C API that emulates OpenSSL's API. So when you choose to use the Russell's TLS library, you have a choice of having it pretend that it's OpenSSL, or you can use a better API, but that's also in C, or you can jump straight to the Rust API if you have a Rust program. So these sort of API compatibility layers around critical Rust libraries are going to be huge for making critical pieces of the internet more memory safe.
I think it's good to kind of touch on this piece, right? Because there's that old expression, because you can, should you do it? And of course, there's definitely a huge amount of people that say, well, these C-based libraries and programs, they've been used for a long time. They're battle tested. Is it really worth it to do it? Or even some people just say, don't do it because, it's just kind of a waste of effort. I'm sure you've heard that argument many times, but I would like to have it kind of recorded on here about what's your position on that and why you still continue to think that it's worth the investment to do all this kind of rewriting and so forth.
First, I would say we've just seen over and over again how dangerous a lack of memory safety can be. So even libraries that haven't had a memory safety issue in a while, If they're written in C and C++, they're almost certainly going to. If they have any significant level of complexity and are widely enough used, eventually you're going to get bitten. The internet's going to be around for a long time. So for some of these critical libraries at the heart of the internet, there's a lot of time for investments and rewrites to pay off. Now, it's true that when you rewrite software to try to get memory safety, you could introduce logic bugs, right? On the flip side, you can also solve them, right, by investing more heavily in tests while you do the rewrite, more heavily in tests than the original project did. Sometimes you just find bugs in the original project while you're trying to rewrite it and you fix those. So, yes, you could introduce logic bugs at a significant enough size and complexity. You probably will, but you also solve some along the way. And you're eliminating the class of memory safety bugs. So if you think of this, if I can describe a graph that people can build in their minds, and think of a graph of bugs, which include logic bugs and memory safety bugs, right? When you rewrite a program, you might have a little bump up in the number of bugs in the short term. You might introduce some logic bugs. But at the same time, that bump is probably not going to be as big as you think, because you're eliminating memory safety issues, many of which you probably don't even know about or never will know about now that you've rewritten your program. So maybe you get a little bump, but that goes down over time. And eventually there's an inflection point where you have ironed out at least the same number of logic bugs in the original program, but now you have no memory safety bugs. And so long term, the line is below the original program, which means it has fewer bugs long term than the original. So yes, you can have some regressions in the short term. Those regressions will get ironed out the same way they got ironed out in the original program. And along the way, you'll have no memory safety bugs. And like I said, remember, there's a flip side. You rewrite stuff, sometimes you fix logic bugs in the original. And we've seen that happen time and time again in our rewrites. So in a lot of cases, it's worth it. Of course, this, in every situation, you got to look at the individualized context. But for our investments, we think it's worth it.
I'm almost wondering if there is some, quote unquote bugs that have now become features that you need to kind of start to implement when you're actually doing this rewriting. I'm guessing there must be some things, right?
Yeah, it happens. One of the biggest things that we focus on when we write software is test harnesses. So writing a lot of tests, often improving on the tests that came from the original program. So we usually take the tests from the original program and get them working against our rewrite. And then we add a bunch more tests on top of that. And when we find behavior that we need to preserve, that gets implemented as a test. There's a great blog post from Tweedegolf, Tweedegolf, which is one of the firms involved in rewriting sudo. And they have a great blog post on their website about tests in the sudo rewrite and the way they invested in test harnesses and how they ended up finding bugs in the original sudo in the process of rewriting it. Security bugs, which got fixed, logic bugs. So we're getting memory safety out of that rewrite, but we're also fixing logic bugs in the rewrite and the original along the way.
Is there ever any projects that are being rewritten that don't have tests or maybe don't have enough tests?
I don't think it's conceivable that we would engage in a major investment that doesn't involve a lot of tests. It's possible that we would rewrite things that don't currently have tests, but then we would write the tests.
That was actually my meaning because if you want to preserve the way things should work, you obviously needed some kind of benchmark, right?
Yeah, so we take the original project's tests, like I said. Otherwise, we will just write them.
So we covered the sudo, suit, and su. How far along are those? Because those would be really interesting to see, and I'm curious if there's any major OSs out there like Linux or et cetera, maybe certain distributions of Linux that are actually going to pull those into their mainline eventually.
Yeah, one distribution has already. We are working with other distributions to try to get that done. The sudo work is, there's an official release. It is ready to go and give it a shot today. We do have a plan over the next 6 to 9 months to add some additional sort of like enterprise level features to it that were not in the original version. So those more advanced features are coming, but I think for the vast majority of people, what's out there today is ready to go. So you can probably find that by searching on GitHub for sudo-rs.
What about the current sudo and the other ones? I mean, those will eventually be phased out, you think? Or, I mean, because they're still being worked on, obviously, right?
Oh, yeah. Todd Miller is the maintainer of the original C version of sudo. He's super nice guy. He was really helpful in giving us advice about our rewrite of sudo. His work continues to maintain the original sudo. It is incredibly important and not well recognized work, I would say. The original sudo is still out there. Obviously, it's much more widely used at this point than our rewrite is. That's going to continue to be the case for a while. So we absolutely hope that he continues to get the support that he needs, which I think he's in a good situation in terms of being able to support the project. I think there's just a lot of maintainers like him out there that people don't know that much about, but he's doing great work. That work is going to continue to be important for a long time.
Now I'm kind of curious. I mean, what do people think about this who are actually, I mean, obviously, we talk with Daniel, we know what he feels like. Obviously, it seems like Todd is very open to working with you and supporting you and your efforts on this. But I almost would feel like if somebody was rewriting something that I did in another language, that maybe I would have some insecurities, you know? How has it been to actually work with these creators or current maintainers?
There is certainly an aspect of psychology to the whole thing. We want people to help. We want people to see our point of view about safety and why it matters and why it's worthwhile to move stuff to a safer language. But yeah, it's totally understandable that people are sort of attached to the thing that they've been doing for a long time. So you get a mix of maintainers that either see the issue and really want to support the rewrite, or maybe they're not as on board as we are, but they're not against it and they want to be helpful. So there's a lot of people that kind of lie in the middle ground where they want to explore what we're interested in doing and they want to be helpful, but it might take a little while to convince them personally that this is like definitely the right way to go. And then there are maintainers who just don't share our point of view. In some cases, that makes us not want to work on the software if it's the kind of software where we really need help from the existing maintainers. In some cases, it's important enough that we're just going to do it, even if the original maintainers of the original software don't love it or don't think that it's worthwhile. Sometimes it's still important to do, and we're still going to do it. But we have definitely run into situations where we are going to rewrite a piece of software and the maintainers just don't see it the way that we do. They think that C is good enough. Take, for example, like a video or an audio codec, right? And in that codec, you have a mix of C and assembly code. And most of the time, when you're talking about runtime, the work is done in the assembly code. It's essentially a loop over some sort of media. So maybe 80 or 90% of the code in the project is assembly. And if we're going to do it, we're still going to use the assembly code, even though it's not memory safe, because something that doesn't perform well enough is not viable anyway. So it's not really worth doing. So, just a quick sidetrack, like performance is really important to us. When we're going to deliver memory safety to people, we do not want them to have to make sacrifices about performance in order to get the safety. So performance is a really big factor for us. And often when we pitch our new software to consumers, we pitch performance first, and then you also get safety with it. So when we do things that need some assembly in order to be acceptably performant, we often will take the assembly. That means that the software is not fully memory safe, but it is typically a lot more memory safe. So back to our example here of a media codec, right? In a normal runtime loop, most of the work is being done in the assembly code. You're looping into that over and over and over again. And maybe only 10 or 20% of the code is C, and that code mostly runs at the beginning when you're consuming the media file or something to do parsing and things like that. You can run into people who say, this isn't really worth it because the new project is going to be mostly assembly anyway. It's mostly assembly executing at runtime. So does it really matter? And the answer is yes, because not everything is equally dangerous, right? Yes, you're in assembly during a lot of the execution, but you're parsing media files that got fed to you off the internet in C before you even start this assembly work for the most part. And that's really dangerous. Look at the release notes for the security updates for any mobile operating system out there, right? Over and over again, it is memory safety errors in parsing code and things like that, just biting people. We just don't see eye to eye on some of this stuff all the time. And that is okay and it's got to be okay, right? Like we can't have our work and the progress of the internet depend on getting everybody onto the same perspective. That's not going to happen anytime. So we just find a way to move forward.
I'm also kind of curious if there's any maintainers who are interested to help out or maybe just kind of watching from the sidelines. And then once the rewrite happens and it works great, that maybe they'd be interested to actually continuing to work on the rewrite rather than kind of continue to work on their own initial project.
I hope that's how it works out over time. I think it's a little early to see much of that. On the other hand, right, like going back to the example of Todd Miller, I do not want Todd Miller to stop working on the original sudo. That's bad for everybody, right? Yes, there is a rewrite in Rust. Yes, I wish the rewrite was more popular and we're going to work towards that. But I don't want Todd Miller to stop working on the original sudo. That's just too important for the internet as it is today. Maybe someday, if the sort of market share numbers swap, that would be cool. But careful what we wish for there.
Yeah, for that sudo, right? Is that actually the same one that's being used no matter which operating system? Because I was just trying to take a look at my own sudo on Mac OS to see if it has his name on it or anything, but I didn't see anything there.
I think the sudo that Todd Miller maintains is by far the most popular one. I don't know if it's the one being used on Mac OS or being used everywhere. I believe there are other implementations of it, but Todd's is the most popular.
It's still pretty cool. I mean, I love the idea and I understand why you're doing this. You did send me this awesome PDF. It's not a huge PDF, but it definitely drives home all the facts. And I love the fact that you brought in, this is about 60, 70%, I believe, were vulnerabilities in macOS were from these memory safety bugs. And then Microsoft has 70%. And then you had another one there. It's like 90% of memory safety issues were vulnerabilities or something like that in Android, right? I think I got some of the wording mixed up. That's huge, though, this amount of bugs.
Yeah. I would say for most of the bigger pieces of software, it ends up being between 50 and 70%.
But 90%? That's huge.
90% sounds a bit high to me. I don't remember that number, but I do remember 70%. There may be projects out there where it's as much as 90%. I think for the most part, the numbers to keep in mind are the range is probably 50 to 70%. But to bring it back to this earlier point that I made, that means that if you move to memory safe languages, you can just get rid of 50 to 70% of the bugs out there. That is huge, right? Like, this is a place where we know how to solve the problem. We have tools like Rust available to us to just make this problem go away. It just is a bunch of work, and we can do work. I would also point out that bug counts are not the only thing. The question is, how severe are the bugs? Memory safety vulnerabilities are often not just the most numerous, but they can also be the most severe from a security perspective.
That's probably my biggest worry because, I mean, so many people use these memory vulnerabilities to actually gain access for a specific reason. I think there was one that helped to kind of capture, I forgot the name of the reporter from Saudi Arabia area many years ago. That was some kind of memory vulnerability issue. It's just crazy the stuff that can happen to you. And it's not like you have to just tap on a link and you're hacked, you're taken over. It's you could just receive a message and you're actually intercepted, which is just insane. People always think, okay, if I just don't touch this link, I'm fine. No, there's many probably different ways that you can get compromised without doing any action at all, which is just the most scariest thing I think of all.
Yeah, this stuff is really severe and people get hurt. And it hurts people every day, physically, financially. And it's solvable, right? Like this stuff just doesn't need to happen anymore. Let's do the work.
Yeah, definitely. And I do remember like a couple times there were some pretty big vulnerabilities that came out, and now that I'm just going to go back to what I have because I have an iPhone, I have a Mac OS, obviously. And like whenever these vulnerabilities come out, I have to actually update three things: phone, iPad, and computer at the same time because they actually share code across. And that's just like, scary that basically like all these different avenues can be compromised.
Yeah. And those updates are just addressing the ones that we know about, right?
Oh yeah, kind of coming back to operating systems, right? So you're also working with the Linux kernel to get the drivers done. I mean, that's a huge step to get in there. I don't know what the process was to get that approved, but the fact that you've made it across the biggest hurdle, that we, I guess we could say, made it across the biggest hurdle of getting approval of this to be put into the kernel is it's quite huge, right? But just for drivers at the moment, Is there still some initiative to try to go further than that? Because I mean, Linux is a huge part of everybody's life.
Yeah, I think right now the focus is on drivers in the Linux kernel. Ultimately, there's nothing restricting it to driver. It's just when you're introducing a new language into the kernel or probably any system, it's better to work with sort of the leaves of the system rather than the sort of central interconnected nodes. So we're going to start with drivers. Eventually, I think it will move to other components of the Linux kernel, but we're going to have to build up from the leaf nodes of the system into the internals. And yeah, I couldn't agree more with how incredible it is that this is in the Linux kernel. I think of myself as a somewhat ambitious person, and when we started Prossimo, I talked a lot about how we just need to be ambitious. Like, yes, these things are difficult. Yes, they're big investments. Yes, it is hard to move the internet onto a different TLS library, but we're going to do it. The one exception for that for me originally was the Linux kernel, because even wanting to be as ambitious as we were, the Linux kernel just felt out of reach to me. It was just too much for me to conceive of a strategy that was going to get Rust into the Linux kernel anytime soon. So it was at the Linux kernel was at the top of my list of targets in the beginning, and we just set it aside. But man, Miguel Ojeda, Alex Gaynor, and some of the others that started the project to put Rust in the Linux kernel, they did incredible work, not just technically, but work to present this to the Linux kernel community, including Linus Torvalds, in the right way, to communicate really clearly about this, to be responsive, just to have the right attitude of, we want to do this thing, but not come off as arrogant or not come off as Rust fanboys or something like that. They did an incredible amount of work, not just technically, but yeah, the way they communicated. I can't believe they got it done. As soon as we realized that this might actually work, we wanted to try to support them as best we could, because it is an incredible accomplishment that is beyond what I thought was going to be possible. I never would have thought that Rust would be officially in the Linux kernel in 2022 or even 2023. I would have just bet against that all day, but they got it done. Great work.
I would love to kind of see how that process happened because that's really difficult to do. I mean, I'm aware of who's in charge of, what can and cannot be in there. And like I said, there's so much validation when you have Russ being kind of christened to be in there because that's not an easy task. There's definitely a lot of people competing.
Yeah.
I'm also kind of curious too about it seems like almost everything that you're working on is using Rust. I have heard quite a bit about Zig. Is Zig a possible choice to actually being used for something?
I'm aware of the existence of Zig. It's not really on my radar. I can't comment much about Zig on a technical level. What I would say about this is that in order for a language to be successful, there has to be investments in the tools and libraries and language itself. There has to be people out there who can write it. So there's a whole ecosystem around a language, right? Whether that's libraries or contractors and things like that. I don't know much about Zig on a technical level. I am pretty confident that Zig does not have the same ecosystem that Rust does built up around it, which makes it a bit of a non-starter for us right now. Maybe that will happen someday. I think it's probably healthy if there is more competition in the systems level memory safe languages with no garbage collection and no runtime space. But I don't know if that's going to happen or not. 30 or whatever years in, C is still the dominant language. C doesn't itself have a lot of competition in the space until Rust came along. So I don't know if that will ever happen, but we need to get work done right now. And right now, when we're reaching for a language like that, Rust is our choice.
That definitely makes sense. I just know that I have heard a lot of good things about it. I believe people have said it's like a safer version of C. Obviously, this is definitely in the same ballpark. Those are two languages kind of get compared, etc. So I'm just kind of curious about is there any other languages that are being looked at as possible uses besides Rust? I mean, I understand Rust is probably one of the top contenders, if not the top contender.
When you need compatibility with the C ecosystem, well, not having a runtime, not having GC, and having great performance, Rust is the only game in town. Our Prossimo, we rewrite most things in Rust because those are the criteria that we need. In theory, we would use other languages, but that's just not what makes sense for most of what we do.
Awesome. I don't think I have any more questions. I mean, is there something that we didn't go over that you think people should know about, or any plugs or anything you wanted to say?
No, great questions. It's a pleasure to be here. If you want to know more, please go check out the website at memorysafety.org. There's updates on all the projects we're working on and a bunch of information about them. And if you want to get involved, there are ways to get involved there.
Actually, I have one question for you. How did you manage to grab such a great domain name? To me, I would have thought that would have been taken.
Yeah, I do not remember the details of it, but I guess we lucked out. Often we have to do sort of private acquisitions of one of the domains, pay a little more money than we would like. Probably what happened here. I don't remember the details.
Okay, that makes sense. Josh, thanks for coming on. It's great to meet you, and I really appreciate all the work you guys are doing. And I'm glad that you can give a perspective on the other side of, just because you can rewrite it doesn't mean you should. I think there's definitely another argument to that for the right use cases, right?
Yeah. Well, thanks again for having me. It's a pleasure.